Good morning students, welcome to our next lecture of data structures and algorithms. In our previous lecture we discussed about linear search or sequential search. So in this lecture we will study about binary search, that means how we can search for the desired element from an array using the binary search technique. So binary search technique is applied only to sorted list of elements. That means the elements that are stored in data structure, those elements should always be in sorted form. If elements are not in sorted form, then we will firstly sort the elements and then we will search for the desired elements from those collection of elements. And the binary search technique searches the given element in minimum possible comparisons. That means it searches the elements in minimum comparisons, that means as minimum as less than as possible. So let's understand this binary search technique with an example. We are having an array. In this array we have 10 elements and all these elements are arranged in sorted form. Sorted forms means either in increasing form or in decreasing form. So all the elements are arranged in sorted form, that means increasing form. That means from left to right elements are arranged in increasing form. So in binary search we need three variables. These three variables are low, mid and high. Firstly we will set the value of low equals to 0, that means the value of low we are taking as 0 because the first element is stored at location 0, and we will take the value of high equals to 9, that means the last element in our array is stored at location 9, that's why we are taking the value of high as 9. And searching number, the number which we want to search in this array is 29. So searching number is 29. We want to search the number 29 in this given array. So for searching the number 29 we will firstly calculate the value of mid. The value of mid can be calculated using the formula mid is equals to low plus high whole divided by 2. That means the value of low plus the value of high, and this whole value of low plus high will be divided by 2. So initially the value of low is 0 plus value of high is 9 divided by 2. Now this will give us the result 4.5. So since 4.5 cannot be taken in this array because no point address is given, so we will always take the value less than. That means less than 4.5 means the round figure less than 4.5 will be 4. So now the value of mid will become 4 and the element which is stored at location 4 is 15. So value of a mid will become 15. Now we will compare the value of a mid with the searching number. The value of a mid is 15 and the number which we are searching is 29. So 15 is not equals to 29. So the result will be no. That means now we will check if the number, that means the searching number, is less than a mid. Searching number is 29 and 29 is less than a mid. A mid is 15. So 29 is not less than 15. That means we will search the element in second half of array. That means second half of array means on the right side of the mid value we will search for the searching element. Now for searching the element on the right side of the mid value, we will take the value of low as mid plus 1 because we are now considering the array on the right side of the mid. So for considering the value on the right side of the mid, the value of low will become mid plus 1. So mid was 4, mid plus 1 means the value of low will become 5 and the value of high will remain unchanged, that is no further elements are present, so value of high will be 9. Now we will calculate the value of new mid. For calculating the value of new mid, 5 plus 9 divided by 2, this will give us the value of mid as 7. Now we will see the element located at address 7. Address 7 contains the value 52. Now we will compare the value of a mid, that means 52, with the searching element, that is 29. Again 52 is not equals to 29, that means the condition becomes false. Now after getting the condition false, we will check the number, the searching number, that means 29 is less than a mid. Yes, 29, the searching number 29 is less than a mid. That means now we will search the element in the first half of the array. First half of the array means we will search the element in between the low and the mid value, because the value of the searching element is less than the mid element. So we will search for the searching element in first half of the array before mid. Now we will search for the element between this new value of low and mid. For searching the value in first half of array means now the value of high will become mid minus 1. Now the value of high will shift to left side and will become mid minus 1. Mid minus 1 means 6. Since value of mid is 7, so the value of high will become 6 and the low value will remain unchanged, equals to 5. Now we will calculate the next new value of mid, that is 5 plus 6 divided by 2, and it will give us the value of mid as 5. Now we will see the element which is located at the location 5. So the element which is located at a mid is 29. Now this array contains the value of low. Low is at 5, mid value is also at location 5, and high value is at location 6. Now we will compare the searching element with the mid element. The searching element is 29 and the mid element is also 29. That means the value at a mid is equals to the searching number, and this condition becomes fulfilled. That means we get the desired searching element at location 5, which we got after calculating the a mid. So this was binary search. Always keep the three variables in mind, the low, mid and high. We will always be using these three variables for calculating the mid value, and after getting the mid value we will compare the value of the mid with the searching element. If the searching element is less than the mid value, then we will search in the first half of the array. If the value of the searching element is greater than the value of the mid, then we will search for the searching element in the right half of the array. So this was all about binary search. I hope you all have understood. Thank you very much.